Okay, so today is going to be our first day of introing our new topic. So this is an intro to polynomials. Intro to polynomials. Today's date is the 25th. And then this topic is covered in your textbook. So if you need to make reference back to any of this, this is in 7.1 of your textbook. Okay, 7.1 of your textbook. So you can always refer back there for other examples and things like that. So to get started, we are going to go ahead and define some words. So that way we all have an understanding when we are talking about this stuff. So the first word is going to be monomial. Okay, and a monomial is a number. A variable. Or the product of a number and one or more variables with whole number exponents. Okay, monomial. The next thing that we're going to do is talk about the degree. Of a monomial. Okay, the degree of a monomial is the sum. I'll write down here, I guess. Of the exponents of the variables in the monomial. If the degree of a non-zero constant, the degree of a non-zero constant term is 0, so the degree of a non-zero constant is 0. The constant 0 does not have a degree. Okay, I don't feel we need to write that down because why would 0 have a degree? Like, why would it be raised to a power? Do you know what I'm saying here? So that just seems like common sense math. Okay, those are what we need to know about monomials. Now we're going to define what a polynomial is. Okay, so a polynomial is a monomial, monomial, or a sum of monomials. Each monomial is called a term of the polynomial. Okay, so then there are two types of polynomials that we normally refer to. One of them being a binomial, and that is a polynomial with two terms. And then we also have a trinomial, and a trinomial is a polynomial with three terms. Okie dokie. Then a lot of information, so you're probably going to need to review this at some point. We are going to look at standard form of a polynomial. So this is standard form of a polynomial. Okay, so standard form of a polynomial would be a polynomial in one variable. So we need a polynomial in one variable when the exponents of the terms decrease from left to right. So we are looking for the exponents to be decreasing, and we read from left to right, so they need to be decreasing from left to right. That's how we know that it's in standard form. When we are looking for the degree of polynomials, so degree of polynomial, that is when the degree of the polynomial is the greatest degree of its terms. So the greatest degree of its terms. And then we have one other thing to talk about, and that is the leading coefficient. Okay, so the leading coefficient, when you write a polynomial in standard form, the coefficient of the first term is the leading coefficient. Okay, so that is a lot of information. So let's write kind of an example about these polynomials so we have a better understanding of what I'm even talking about, because for some of us, this is not making sense yet. So let's say I have 2x cubed plus x squared minus 5x plus 12. Okay, I might have something that looks like this. When we're looking at this, we are going to be identifying that here, this 2 is going to be my leading coefficient. So leading coefficient. That this 3 here is going to be the degree. This here, that is my constant term. Or if you think back to course 2, probably with me, I would give dating advice at this point where like, it's the constant because it has no dates to the dance, right? It's the number by itself. When we talked about simplifying expressions back in course 2. So we should be somewhat familiar with that as well. Okay, so this is the information that we just discussed in terms of what we are looking at for a polynomial. Do I have any questions so far? So we're going to do some examples together. The first one is this. Find the degree of each monomial. So find the degree of each monomial. So if we go back and we look at the degree of the monomial, it is the sum of the exponents of the variables in the monomial. So we're looking at the exponent. So the exponent here is raised to what power?
The first.
Okay. So then the degree here would be?
One.
1. Thank you. Okay. Here, my degree would be?
4.
4, because I'm adding the exponents together. Okay. On C, my degree?
3.
And D, my degree?
0.
0. There's no exponent here. There's also no variable. So if it's just a constant, the degree is 0. If I have one variable with no exponent, the degree would be 1. If I have multiple variables, I'm adding up the exponents to determine the degree. Okay. Write -8 plus 9x squared minus 2x in standard form. Identify the leading coefficient of the identify the leading coefficient and degree of the polynomial. Okay. So first thing we're going to do is write this in standard form. So we start with the highest exponent. So this would, and we go from left to right. So squared is the highest. So I have 9x squared minus 2x minus 8. So I'm looking at the degree of the polynomial. Now the degree of the polynomial is different than a monomial. Okay, the degree of a polynomial is the greatest degree of its terms. So I'm looking for the largest exponent. So the degree here is 3. Oh, I'm sorry, that's a 2. Holy moly. Sorry, couldn't read my own handwriting. Okay, a 2. So again, we are looking for the greatest degree of terms. So greatest degree of terms. Okay, so the degree of the polynomial is 2, and then the leading coefficient. So leading coefficient is 9, right? It's the coefficient that is starting off my polynomial. Okay, let's take a look at this. So we are going to write each polynomial. So write in standard form. Identify the degree and classify the polynomial by the number of terms. So identify the degree and classify by number of terms.
Misha,
Yep.
when you say classify, does it mean like, is it a monomial, polynomial, binomial, or trinomial?
Yep.
Okay.
So we're going to go ahead and look at this first one to write.
Misha,
Yes.
is b negative b squared plus 2b to the power 4 plus 6b?
Yeah.
Okay, thank you.
So starting on this first one, We're starting with our variables and exponents first, decreasing. So standard form would be 7a squared plus 3. The degree here would be 2. And the type, so how many terms does this have? 2. So it is a binomial.
Binomial.
Okay. Here we go. We're writing this. Biggest, greatest to least. So this is going to be 2b to the 4th minus b squared plus 6b. When we look at this one, the type here is going to be a trinomial because there's 1, 2, 3. It's going to be a trinomial. And when we have a trinomial, my degree goes along with the largest exponent. So the degree here is 4. Okay, down here, my type is going to be a monomial. It's already written in standard form, so I don't need to rewrite it. And then my degree here is 5. Okay, so that is like the baseline of polynomials. That's the intro. So now what are we doing with these things? We are going to be looking at how do we add and subtract polynomials. So this would be like find the sum. Find the sum. I have 3x squared plus 4x plus 3 plus 2x plus 5x squared plus 1. Okay, I'm hoping this looks like stuff you have done before because this is very similar to course 2 and combining like terms. This should feel very similar, right? So what we're going to be doing is we're going to be looking for like terms. So in order to be a like term, what do things have to have in common?
You have to have the same base and exponent.
Okay, the same base and the same exponent. So let's look at this. This is an x squared and this is an x squared. Those are matchies. So those simplify to be what?
8x squared.
8x squared. Okay. This is a x and this is an x. Those are matchies. Those simplify to be 6x. I have a constant and I have a constant. Those simplify to be 4. There you go. I'm done. Okay, again, that should feel familiar. Okay, let's take a look at this. We are going to find the difference. So I have 3y squared plus 8 minus 6y squared plus 4y minus 2. Okay. What is our first reaction of what we should possibly do here?
Distribute the negative to 6y squared plus 4y minus 2.
Okay, so I could distribute the negative to my trinomial. So this would then be a rewrite of 3y squared plus 8 minus 6y squared minus 4y plus 2. If I distribute that negative. And then if I go about combining like terms, this is a y squared, that makes negative 3y squared. I only have one single y here, so that's a minus 4y. And then a constant, and that makes 10. And so there I have it, done. Okay. Both of these examples here are looking at the horizontal format for how to go about doing this. You could also use a vertical format to do this in. So it's really dependent upon what you feel most comfortable with. If I was to do this in a vertical format, the first thing I would do is I would rewrite this to be in standard form. So I have 3x squared plus 4x plus 3. And then I'm going to have 5x squared plus 2x plus 1. And literally I'm stacking them like, I don't know, first grade math style. I don't know how else to describe that, right? So we're just going to stack them. 3 and 1 made 4. This makes 6x. I bring down the signs with them. This makes 8x squared. Okay, nice, simple, easy. This would be considered the vertical form. This up here is horizontal form. Same thing if we look at this here as far as going about stacking these, you could, I'm going to write the first one first. So I have 3y squared plus 8, and then this is a minus 6y squared plus 4y minus 2. And if you want, like, you could
Isn't it a minus 4y?
in my original problem.
No, isn't it like, aren't you supposed to distribute the sign?
Well, I'm doing something else right now.
Oh, okay, that
I'm
makes more
teaching
sense.
a different method. So what I'm trying to teach is how to stack it, not distribute, and it's not horizontal. So when I look here, this and this is not currently lined up, so we might want to move that over. And you may want to throw in a 0 here, right? Just to kind of keep your stuff lined up. Because when we lose track of place values, sometimes that gets confusing as well. So we are subtracting here, so I can go ahead and start over here. So this would be 8 minus negative 2. So 8 minus negative 2 is really an 8 plus 2, so that made 10. This is going to be 0 minus 4y. So that makes a negative 4y. And then here I have 3y squared minus 6y squared, which makes a negative 3y squared. Okay, so again, this is just another way you can do it. Okay, there's not a right or wrong way. It's whatever you feel most comfortable with in terms of how to go about solving these problems. Okay.